Educational Studies. It's a time to introduce the every speaker of the day. Every thought you produce, anything you say, any action you do, it bears your signature. I'm profusely elated to take an opportunity to introduce our speaker of the day, Dr. Ananda Sivapragasam, who is currently working as an associate professor in G. Venkateswamy Naidu College, Kovilpatti, since 2019 to present, with over 22 years of experience in teaching and more than 6 years of experience in research. Sir was awarded Mission 10X from IPRO and received research awards by PSR Engineering College, Sivakasi. He is also a dedicated professor with a strong work ethic and a commitment to excellence in teaching. He has published many papers in various journals in the areas of image processing, soft computing, and artificial intelligence in biomedical engineering, pattern recognition, so on. Besides this, he has organized many national and international conferences, projects, and workshops. He has published various books and journals in Scopus. He has served as a member of the editorial board of several journals in the area of computer science. He is also a life member of IEA, ENG, and then IFERP, and so on. One day is not sufficient to share the resource person's profile, which includes more than 12 pages. I am very happy to introduce such an eminent person amidst us. I hope we all can gain knowledge from him for our growth. Let your addiction for growth be stronger than your addiction for comfort. Once again, we welcome you, sir. I welcome all the participants for the second day of the 7 days International FDP. Once again, I welcome you all. I request our speaker, Dr. Ananda Sivapragasam, to take over the session.
Thank you, ma'am. Thank you for your nice introduction. So, very good afternoon to all professors. My voice is audible. Very good afternoon. Yes. Very good afternoon to all professors. First of all, I thank the management and principal and vice principal of our college and the different conveners, and also organizing committee members for giving these opportunities to deliver the lecture on introduction to robotic systems. Ma'am, can I share my window? Yes. My window is visible. My window is visible.
No, sir.
No.
Kindly share your system.
Okay, just a minute. Now it's visible.
Yes, sir. It's visible.
Yes. So what topic we are going to discuss is introduction to robotic systems. Why I'm taking this robotic system is that is a lot of reason. The first reason is called after 20 or 30 years, India will become the major part of producing robotic system, because we are having the number of MOU with the Japanese companies, and also robotic system may replace the human being after 30 or 40 years. So it plays a vital role in our development. So that is why I'm taking the introduction to robotic systems. So I think in the last 6 or 7 months back, a hotel in Chennai introduced a robotic system for serving the food customer. That is why I'm choosing the specific topics. It's purely what is called as a technical oriented, and somewhat I'm lightly touch the technical, and remaining part is what general one. What is robotic systems? We have the number of definitions for the robotic systems. So here the robot can be defined as a programmable, self-controlled device which consists of electrical, and mechanical units. What do you mean by that? It is a combination of electronics, electrical, or mechanical units. Apart from that, the computer devices. So this is the one definition is given, and apart from that, one more, we have the number of definition. I'm giving the three or four definition. So first one is common. Robot can be defined as a programmable, self-controlled device which consists of electronics, electrical and mechanical devices which are controlled by the computer program. And second one, a second definition of this, robot is nothing but a mechanical apparatus and that is used to do our work. So do our work. So it consists of electromechanical device. It consists of electromechanical devices that is guided by the either software program or electronic circuitry. So that is another definition. So first one is what is common, and second one is what is called. It is related to the industrial. And third one is that is given in the British Robot Association. Industrial robot is a reprogrammable device designed to manipulate and transport a parts and tools or whatever it is. So that is what the industrial robot is used. So why they are giving the different definition? The robot can be used in almost in all sectors of the society, all sectors of the society. So on which the industrial robot is very, very important. Industrial robot is very, very important because most of the robots are used in industrial. Okay. And third and fourth one is robotics, the engineering science. It comes under our part. Robotics, the engineering science and technology of robots and their design, manufacture, application and structural disposition. Okay, it working what we need, it requires a working knowledge of so all the things that is called electronics, mechanic, and software, as well as electrical work, electrical. So these are the I'm telling the four definition of this one, and each definition will be differ from one another. Okay, and next, the robot name is coined in the year 1921. That is used by the Karl Kappa. In 1942, the robotics word was used, and that will be presented three important laws of robotics. Okay, first law means what? Robot must not injure human. And second, it should be obey the order. And third one, it should perfect their own existence. So these are the three laws prescribed by the Isaac Asimov, who coined the robotics name in the year 1942. What are the essential characteristics of robot? Yes. What are the essential characteristics of robotic systems? So every robot system has some kind of characters. So on which important one is what? Sensing. Sensing means what? It senses surrounding. Senses surrounding. How is senses surrounding? With the help of sensor. With the help of sensor. That is called first important character. Sensing means what? We are getting the information from your surrounding. Okay, and the type of sensor, what are the type of sensor we are having? Light sensor, touch sensor, hearing sensor or chemical sensor. Light sensor means nothing but eye, touch sensor is hands, hearing sensor ear, chemical sensor is nothing but nose. And movement, what kind of any kind of movement can be carried out in the robotic systems. So movement should be specified. It may be a rolling or walking, a snacking, a scatting. Okay. So movement is very important. Movement is one of the important characteristics of the robotic system. Energy. How we are giving the energy for the your robot. So through the batteries or power generator or fuel. So robot needs to be able to power itself, which depends upon the what power source you are using, whether you are using the batteries or power generator or fuel. And intelligent systems. So you know that intelligent. So some robot should be intelligent and also it should be smart, and that is given. That is given by the programmer. I'm writing the program that should be intelligent one. So these are the four important characteristics of the robotic system. First one is sensing, movement, energy, and intelligence. How tackle the issue of industrial relationships? We have the association of the robotic system. that is called Robotic Industry Association. Though this association give the three promise that very important. The robot does not replace the worker; it just replace only the requirement. That is the first promise given by the RAA. And second one, it is used only for this kind of hazardous, boring, demoralizing, and repetitive tasks. And second one, it can only result in shorter work week, higher pay, and better working condition for human being. So these are three promise are given by the RAA. Then only the industrial relation can be maintained. So how can you say that this is the robot? How to qualify this is a robot? So it contains the four important factor: sensing and perception. Sensing and perception means what? We are getting the information from its surrounding. The sensing through this sensor, we have the number of sensor we are having. Through this one, we can get the information from the surrounding and carry out the different task. So what are task? So using the robotic system, we can perform a lot of tasks on which locomotion or manipulation or production unit and physical movement of the object. Okay, then reprogrammable can do a different things. So one robot can be used for one robot is used for picking the material. After that you feel that it should do some other work, so we have to reprogram it. And it should function autonomously and or interact with the human being. It should function autonomously and also interact with the human being. Sometimes it may be autonomous, sometimes the human interaction is very essential. Why use the robotic system? That is a number of reasons for that, but I am display only the central reason. The first one is application 4D environment, and that is used in the dangerous places, and in case of volcano or in a nuclear bomb blast. Okay, then dirty or dull, the domestic cleaning in the dull difficulty task, cleaning inside of anything else. So very then apart from that, automation, augmentation, assistant, and autonomous. So these are the tasks. Because of the task, we can use the robotic systems. What are the limitation of robotic system? We have the it is not a creative and innovative. Robot is not a creative innovative. Whatever command you are given, based on your command, it perform the task. It is not a intelligent robotic system, so it is not creative and innovative. And it cannot take the complicated decision. Nil. It does not take any decision. It adapts quickly to change in their environment. So adaptability is not possible as far as robot is concerned, but human beings can adapt it with any kind of surrounding. Okay, it think independent, it cannot think independently. And next one, that is the characteristics of the human being, cannot learn from mistake, but human being can learn from mistake. So these are the limitation of robotic systems. What are the types of robotic system? What are the types of robotic system? So mobile robotic system, industrial robotic system, domestic household robotic system, medical robotic system, service, and military robotic system. And mobile means what? It can be moved around in the environment, not fixed in a one physical location. Industrial robot is what? It is used in a industrial manufacturing environment. That is what are the tasks carried out in the industrial industry? Welding, material handling, painting, and other kind of tasks, or pick up the material, etc. Domestic or household robots. Some kind of robot can be used in the house also, or in the domestic. So that is nothing but a vacuum cleaner, robotic pool cleaner, or sweeper, etc. And medical robot, that is used for surgery. Surgery. But as far as surgery robot is concerned, it is not fully utilized in the medical field. It is in a trial phase. Service robot. The robot does not fall in any other type. The robot used for research. Robot used for research, and military robot, and these are used in the bomb disposal and bomb disposal and different transportation of robot and etc. Drones in the even in the drones are the military robot is used. And this is the industrial robot, simple example for the industrial robot. So these are the different application of industrial robotic system. Why I'm insisting on the industrial robotic system? Most of the robots are almost 80 to 90% robots are used in the industry. Okay, material handling, polishing, punching, welding, palletizing, assembling, laser cutting, spray painting, inspection, debarring. These are the different application of industrial robotic systems. This is called military robotic systems. So this is called entertaining robotic systems. Entertaining, it is a music or some other purpose. What is the advantage, usage, and advantages of the robotic systems? It almost it touch in the all sector of the society. That means what? It penetrate in the all sector of the society. So it is used in vehicle and car factories for manufacturing car or moving a car, so etc. For that purpose we are using. Okay, then mounting circuit on the electronic devices. Nowadays they are using the machine shouldering. The machine shouldering is very thin. We cannot use the man handheld shouldering. Okay, that is why we are using the robotic system, and this is used in the danger place. Take for example nuclear leak, bomb disposal, etc. And surgeon, so brain surgery, even brain surgery, even in the complicated surgery the robotic system can be utilized. But how far it is successful, it is $1 million question. And also it is used in the mail delivery, used in the mail delivery uh, throughout the building in the large corporation. Then toy robots, that is used for entertaining purpose, that is called dancing, talking, and moving, etc. And one more, the robot never get bored, and they can work up to 24 and 7 without any salary or any food. So these are the advantages of using the robotic systems. Almost it penetrate in all the sector after 30 or 40 years. Even all work are carried out by the robotic systems. So disadvantage of a robotic system. Already I am telling the robotic system that is not innovative. Apart from that, it needs high supply of power, and ultimately if all factory are introduce the robotic system, normally number of job will be lost for the youngsters. It needs maintain it needs maintain to keep it running. It cost of the robot is very high. Robot cannot respond to time in time of danger. So these are the another disadvantage of using this one, but it needs high power. Because of the robotic introduction, most of the job may be lost, and you have to maintain all the things. It needs a lot of money to buy or even assemble, and it cannot respond in a time respond in time of danger. And another important factor, it is not a purely computer engineering subject. It is not a purely computer science engineering subject. It is a combination of mechanical, electrical, electronic, and computer science. And as far as mechatronics is concerned, it is a combination of mechanical and electronics. So it is a robotics, not purely computer engineering subject. It's a combination of mechanical, electrical, electronics, and computer science. And again, here we have the industrial robotic that is used for different purpose. I already explained what is robot. It is just like a machine that looks like look like a human being and act as a human being. Okay, it is more efficient. It is more efficient, but insensitivity a person. It is automatic apparatus. It is guided with automatic control or manual control. Okay, the computer whose main function is to produce a motion. Okay, how it will move from one location to another location. So important characteristics of the robotic systems, already essential characteristics. This is important. Repeatability. For repeatability purpose, we have to use the robot and manual control. So we have the two kind of control, either manual control or automatic control. And speed of operations. Speed of operations very high when compared to the human being. And if speed is increased, automatically cost will be reduced. So manufacturing cost will be reduced. Manufacturing cost will be reduced and labor cost will be reduced. If it is an automatic system, so normally if you automatic system as well as speed of the operation is included in the factory, what will happen? So manufacturing cost will be reduced. Manufacturing cost will be reduced, and we need less labor. But what ultimate effect means what? It reduce the job opportunity of the youngsters. Now let us see the what is the architecture of the robotic systems. What is the architecture of the robotic system? So in the industrial robotic system, we have the several electrical and mechanical component. They are acting together as a system. We have the controller. Here controller is nothing but a operating systems. We have this operating system for robotic and software. What is the use of the software? Which detect how the system operate and communicate with the robotic systems. Okay. Then sensor. What is the use of sensor? Which is used to collect gathering the information. That is called localizing or positioning. So this is called the architecture of the robotic system. We have the industrial robot, we have the internal sensor and also external sensor. Here the program is written by the programmer. We have the control unit that is called as operating systems. Okay, industrial robotic. So the internal sensor receive the information from the mechanical structure, and that is sent to the control unit. So based on the information received from the internal sensor as well as program, the control unit send the corresponding command to the mechanical structure through the actuator. So that is what is called actuator is nothing but a electrical machine or hydraulic, pneumonic or artificial muscle. Okay, we can use any kind of sensor. Sensor may be a normally camera or encoder or photo electronic or GPS. So these are some of the sensor we can use in your system. Okay, this is the entire architecture of the system. So what we have, industrial robotic system. So industrial robotic is controlled by the control unit, and we have the two kind of sensor, internal sensor as well as external sensor. And this is the external sensor in the environment. This the duty of the sensor are collecting the information from the surrounding and send it to the program or control unit. Then it receives a command from the software. Based on this one, the control unit send the corresponding command to the mechanical structure. And configuration of the industrial robot, on which the manipulators are very important. Manipulators are very important, and that they are divided into 6 based on its configuration. Okay, the first one is Cartesian, second one is cylindrical, and third is spiral, scara, uh, articulate and revolve, and last one is robot. So these are the different configuration of. Hello. 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 Yes, ma'am.
Yes, sir.
There is a disturbance from your side, and somebody
Yes,
now
sir.
it's
Give me that.
yes, now it's clear. Yes, clear, ma'am. Okay, Cartesian, cylindrical. These are the 6 manipulators are available based on the configurations. The Cartesian, the Cartesian type configuration that is called X, Y, Z. That is, it formed by the prismatic joint, prismatic joint. Okay, whose joint axes are coincide with the X, Y plane. The white is used, and these robots are moving in 3 direction. This kind of robot is moving in 3 direction: X, Y, and Z plan. It mainly used for tabletop assembly application, and also it is used for transfer the material and cargo. Okay, so it is a 3 prismatic joint which axes are coincide with, which axes are similar to the X, Y, Z. So it is moving in the it is rotate in the 3 direction, X, Y, and Z direction. It mainly used for tabletop applications. What is assembling the mobile phone, or assembling the what is called motherboard, etc., and transfer of medical and cargo. And what is the main advantage is what? It is a 3 linear axis. It has the 3 linear axis, and we can easily visualize. It is called a structure is very rigid and easy to program offline. As far as robotic system is concerned, we can write the program either offline or online. Okay, easy to program offline. And one the demerit is what? Access hard to seal. It needs a large space, and it can only reach in the front of itself. So that is the demerit of using this one. And SCARA. So the SCARA means selective compliant articulated robot for assembly. Selective, that is the abbreviation of this one. Selective compliant articulated robot for assembling. So we have the 2 type of robot. One is first 2 joints are revolved, and third revolved with the third joints as a prismatic. The first one is what? First 2 joints are revolved, but third one with the third one. In the second case, first one is revolved with the second and third. You see, you understand? This is the concept of this one. Okay, 3 linear axis, 2 rotating the axis. Height axis is rigid. Okay, 2 way to reach a point. But only disadvantage is what? It is very difficult to write the program in offline. It is highly complex ARM. And revolve type configuration, that is called RRR, revolve type configuration, alpha, beta, gamma. Also called as, it is also called as articulated manipulator, that look like an arm with 3 rotate joint. And it will mainly used in the industry that is called welding, painting, gunnery, and conveyor system used for moving the part from one place to another place. Welding, painting, it mostly used in the what is called industrial. That is called 3 rotating. It has 3 rotating axes, 2 or 4 ways to reach a point. It needs large work area for at least workspace. And demerit is what? It is very complex manipulator, and it is very difficult to write a program in offline. And last one is parallel type. So this is called a parallel type, and advantage is for it is less motion, disadvantage less motion. Kinetic can be challenging, and motor can be fractional. It has a higher bandwidth and easier to control. We can easier to control where it is easier to control. So again, I will give the figure for this one. This is called Cartesian robotic system. And this type of use the X, Y is a 3-dimensional coordinate system to control movement and location. This is the example for this one. I'm having the X, Y, and Z direction. It may be X, it may be Y, and Z direction. It may move on the 3 directions. And Ganary robotic system or Cartesian robot that can be super size. Size will be very large. What is the use of this one? It minimizes the deflection on each axis. And this is called a cylindrical robotic. That is why I'm sure the image of each and every robotic system, then only we can understand. Main axis that is in the center we have the main axis of the operating angle. It can reach into the tight areas without sacrificing a speed or repeatability. So it will be surrounding based on the center of the operating envelope. So this is another example for the cylindrical robotic arm. Spiral robotic system. It is similar to cylindrical robotic system. Okay. And but form a spiral range of motion using the polar coordinate. Polar coordinate. Okay. It is similar to cylindrical robotic system, but form a spiral range of motion using a polar coordinate system. SCARA robotic system. We have the 3 joint selected and arm. It is combination of articulated arm, cylindrical, and we have the 2, 3, and 4. We have the 3 arms is there. So this is another example for SCARA robot system. Articulated arm robot system. Already I explained, but with this figure I am explaining all the things. Sorry. Have at least 3 rotatory joints. We have the 3 rotatory joint. They are frequently called as anthropomorphic arm. Anthropomorphic arm. This is similar to human arm. This is similar to human being arm. It has the 3 rotatory joint. 3 rotatory. There is 1, 2, 1, 2, 3. Parallel robot is fixed to base a platform by means of number of legs. We have the number of legs. This type of robot is used to create the realistic flight simulator. A realistic flight simulator rides in amusement park. That is what this kind of parallel robot is used. We have the fixed base to a platform by means of we have the number of legs. So these are the different manipulator I'm showing already. I'm showing another example for the Cartesian, cylindrical, spiral, hand, coordinate, SCARA, and articulator RR. And robotic classification. How you classify the robot? So based on the arm configuration, we already studied the different arm configuration: Cartesian coordinate, cylindrical coordinate, spatial coordinate, square coordinate. And the drive system, based on the drive system, what drive system you are using. So what is that means what power you are using for the robotic systems, and that is called whether you are using the electrical system and a hydraulic system or pneumonic. Drive here system. It is a direct drive robot or geared robot system. Direct drive robots or geared robot. So these are the classification based on the arm configuration. Already we are familiar. Drive system, how the robot is running, what power is given, whether we are giving the electrical power or hydraulic power or pneumonic power, and what here is you are using. The next what level of technology, what level of technology you are using, whether you are using the low level, high level, or medium level technology we are using. The low level technology is low level technology used for material handling and simple assembling. And medium technology is used for pickup and place and material handling, and that insists of 4 to 6 axes. So totally we have the 6 axes. uh, we can use 4 to 6. And the last one, a high technology, and that is used for pick at place, loading, painting, welding. On this case, high technology is used. And field of application. So what is a field of application? Field of application, it may be used in the industrial, or it may be used in the medical, or it may be in a space, or it may be used in the aerial, or in the military, etc. So based on this one, the robot can be classified. Okay, tooling application. What are the tooling application you are using? Painting robot, whether you are using the painting robot or welding robot, clearing robot, debarring robot, and it is robot. These are the different robot you are using. So based on this one, robot can be classified. Robot can be classified: arm, drive care system, what technology we are using, what kind of field the robot is used, or what kind of tooling application is used. Based on this 1, 2, 3, 4, 5, the robot can be classified. Motor actuator technology. What is the motor and actuator technology used in the robotic systems? So commonly used actuators are mnemonic. Mnemonic, whether you say it is a efficient, energy efficient, hard for feedback control. You know that what is called electrical system. Actuator can be mnemonic, electric, or hydraulic. And what is the use of this one? And mnemonic means we are using the mnemonic, energy efficient, hot for feedback control. If you are using the electrical, it is clean choice of today because electricity normally now we are using. Hydraulic, hydraulic is used for large forces. Okay, and that is used for bulky leakage problem. Bulky leakage problem. And then electrical device, electrical drive. So let us take the electrical drive. So it is used in the small and medium size, small and medium size robots are powered by whom? Electrical drives. Electrical drive. So advantage is what? It is better accuracy and repeatability. It needs less floor space. And the third advantage is what? More towards precious work such as assembly application. What is the demerit of this one? Speedy and powerful as hydraulic robot and expensive for large and powerful robots. Hydraulic larger robots are powered by hydraulic drive, okay, and that provide the rotational motion. So main advantage is what? Strength to weight ratio can also be actuate a high speed, but one demerit is what? Require a large space. We need a large space. Okay, and tendency for oil leakage. Right. The last actuator is a pneumatic drive used for small robot that possess a fewer degree of freedom. We have the fewer degree of freedom means what? Totally we have the 6 degree on which we can use it 2 to 4 degree. So demerit what? It requires large floor space, tendency to oil leakage, but advantage is what? It is cheaper and lower technology option for control of speed and safe to use a light is weight. So these are the different components used in the robotic system: manipulator, controller, power supply, and vehicle. So controller, I can show the controller, power supply, manipulator, and vehicles. So these are the important components of the any robotic system. Whatever robotic system we are designed, maybe the size may be differ or structure may be differ, but these are very important. And manipulators already can be divided based on the configuration. Already you studied the Cartesian, cylindrical, scara, polar coordinate, join them. Apart from that, you have the wrist and gripper. Okay. Apart from that, wrist and clipper. Manipulator contain the wrist and clipper. So already you know that power supply, either whether it's a pneumatic or electrical, hydraulic power can be used. These are the important common. Already shown in the previous slide. Controller. So what is a controller we can use? Servo system. It may be a open or closed. Operating mode. What is operating mode? We can use only by the pickup and place or point to point or continuous path. Okay. So now next we are use the vehicle. Vehicle may be a stationary or it may be movable one. Whatever you can choose based on your application, we can choose the vehicle. And same as operating mode, we can choose based on your needs or based on your application. It may be pick up and place, or it may be a point to point, or it may be a continuous path. And what are the parts of the robot system? Manipulator, pedestal, controller, end effector, power source. Already we are familiar with the manipulator. So manipulator is nothing but it what is called is similar to the human arms. So what are the things it has? It has a face. Apart from that, it has a appendage, shoulder, arm, and creeper. Apart from that, it has a appendage. So some material component can be added with the base, that is called shoulder, arm, and creeper. We know that in the latest slide we can see what is called shoulder, arm, and creeper. Pedestal, and it support the manipulator, act as a counterbalance. So that is what the pedal is used, pedestal. And controller, you know that is control is nothing but a operating system. Issue the instruction to the robot, it controls the peripheral device and interact with the robot, interface with the robot, interface with the external devices. That is what the control is used. So end effector, the end effector, this is called the red color is called end effector. And spray paint attachment, attachment whatever can be a end effector. It may be a spray paint attachment or welding attachment or vacuum heads or hands or creeper, whatever end effect we can use. So the red color can be changed by the welding attachment or vacuum guts or hands, whatever it is we can use based on your requirement. We can change the end effector. Power source, already you are not. So the robot can be powered by either by the electrical or pneumatic, hydraulic. It depends upon the what kind of robot you are using, what kind of robot you are using, and what kind of task you are going to carry out. If it is a smaller task, electrical is okay. It is a medium, is okay. It is a heavy work, we can use a hydraulic power. Hydraulic power can be used. A robot classification, this is called freedom of degree. So line, it's move in the x direction, it is move in the y direction, it is move in the z direction. And these are the totally we have the 6 direction, right? And degree of freedom, that is what I am explaining again. Robot base of arm, pivot base of arm, blunt elbow, wrist up and down, wrist left and right, and rotate wrist. So these are called different degree of freedom. Different degree of freedom. We have the 6 degree of freedom. And robot classification, 6 degree of rigid body can be described using the nautical terms. It may be moving up and down, that is called heaving. Moving left and right, you can move left or right, because we are using the rigid body. Moving up and down and moving left and right, moving forward and backward, and tilting forward and backward, and tuning left and right, tilting side to side. These are the 6 degree of rigid body can often described as a nautical terms. So if you are using the rigid body, this 6 operation we can do: moving up and down, moving left and right, or moving forward and backward, tilting forward and backward, turning left and right, tilting side by side. And robot important components: robot manipulators are rover. So already you are familiar with the rover, and recently our India launched a satellite to the moon. The rover is landed in the moon, but it's not properly landed in the moon. Okay. And end effector, whatever it is, we can end effector maybe a gripper or hands, whatever it is we can use. Actuator may be a step up motor, or you can use a hydraulic cylinder. Sensor, whatever sensor, based on your needs, based on your application, we can use any kind of sensor. We can use any kind of sensor. Controller and processor and software. Controller which control the entire robotic system. What is a processor? The main brain of the robot. It calculates the motion and velocity of the robot joint. And you know that software, robotic software is available. Apart from that, we have the number of soft, some number of routines. Then gripper. So that is called end of the arm tooling. This is called as end of the arm tooling. Either it can make or break the robotic project. So because that gripper can do the all kind of work, even though the system give the control, give the instruction, the gripper can be, do all kind of work. If it is make or it may be break the robotic projects. End of arm tooling, general class of device are called as end of tooling. It is not limited to the various kind of uh, this is not necessary, but let us go for end of arm tooling. So any kind of creeping tools can be used at the end of tooling. The first creeper design just like the what is called human hand gripper. First gripper design, the first gripper which was designed resemble more to the human hand. Later it realized to design the creeper along to the requirement. Okay, the initial creeper, the first creeper was the human hand. Later, based on our needs, the creeper can be improved. And what is the difference between robotic hands and the human hands? Robotic hands and human hands. Robot end effector that pick up the heavy object, corrosive substance, or even it pick up the hot object or weaken the sharp object, and even it is a dangerous object. Not good at handling the complex shape and fractal items. Okay, we cannot use a complex shape. You cannot pick up the complex shape. So the shape may be changed or it may be fractured or fractal items. Don't have the good tackle sensing capability. Don't have the any sensing capability. So when you are picking the very sharp images, it may be broken or it may be damaged. So the only advantage is what? It pick up the heavy object, corrosive subject, even if they pick up the hot object or in a soft object, even if it is a very dangerous object, we cannot touch that kind of object. How creeper work? Okay, so we have the creeper. Creeper can be a 7 different method to grip a part. You just grabs it, cook it, scoop it, inflate around it, attract it magnetically, attract it by vacuum, stick to it. So these are the different method to grip any kind of part. So we are using the gripper. Gripper can be hand or whatever it is. Based on your needs, we can design your gripper. Okay, the creeper can do this kind of operation. So be the design specify the operation. A type of robotic grip, vacuum, cup, electromagnetic clamps or mechanical gripper, scoop, ladle or cups, cooks hands with the 3 more finger, adhesive or stiff up sticky type. I'm telling this one, the name is somewhat very difficulty. When we see the figure, we can understand. These are the different type of robotic I'm using. I'm not using use in the industry or industry. So these are called 3 cans we are having. What is called this is called 2 ring. This is called either 1. This is called 2, and these are the different types of robotic creeper. Inflatable flatter, 2 finger clamp, 2 finger clamp, 2 finger vacuum cup, 3 finger clamp, 3 finger clamp, magnetic head, dumping pickup devices. These are the different type of robotic creeper. So it is so we can use any kind of robotic creeper based on your requirement, based on your requirement or based on your applications. We cannot include all the things at one time. And power for creeper. How we can give the power for the creeper? See, it needs independent power supply. Independent power supply is required for this kind of creeper. Independent power supply is required for this kind of creeper. That is 4 type of powers are used for creeper. Already you are familiar with this one. Pneumatic, electric, hydraulic, and springs. Whatever, sorry, I'm using the four type. Here we are using the four type of power. They are used for creeper, mnemonic, electrical, or hydraulic springs. So we can use any kind of power system based on your needs. If it is very high, we can use a hydraulic. If it is small or medium, we can use a electrical. Then control unit. That is another important factor in this. So that is the brain of robotic system. Okay, it is the brain of robotic system. Servo system that may be a open or closed loop. It may be a open or closed loop. Operating method of robot control unit. Okay, it may be pick up and place control unit, point to point, continuous path control unit, continuous path control. So these are the operating modes of the robot control. Pick up and place control. So normally what kind of power is used? A mnemonic. It is because it is simple. Mnemonic power is used with no position information feedback. It is open loop servo control robot is used here. We have the two type of robotic, open and close. Here we are using open loop servo control robotics. Sometimes it is called as a low technology control unit. Low technology control unit. And pick up and place control unit. Move a robot from starting position, grips a part, remove the part from the machine, move to second position, deposit part, prepare to start another cycle. So these are the different sequence of operation carried out by this unit, that is pick up and place control unit. Point to point control, it can reach any point within its work envelope. If we have the work envelope is within the factory, it may be moved from within the factory, not out of the factory, and have any number of points in your work sequence. So we can have any number of stop point. So in the package unit, we can have one point. In the delivering part, we can have one point, whatever it is. It is called as medium technology control unit, and that can be programmed by the programmer. How robot can be moved. So already it's a pre-program because it is a repetitive task. And point to point control, point to path between the point, no predictable. What kind of motor here using? That they are using stepper motor. Stepper control motor used here. It is not point to point, it is not predictable. I am telling this point to point, it may be moving from one location to another location, but the point is not specified. It is not specified previously. Continuous path control, it can reach any point within his workplace, can have any points in the sequence as a particular task. It is more expensive, and that use a high technology control. And one more is it needs large memory capacity. It needs large memory capacity. So it have the any point, we can have any point within the envelope. Okay, it is called a high technology control unit. But the two merit is that it is very expensive. It needs a large memory capacity because all programs should be stored in the memory. So mobile robot, the wheel configuration, center of the gravity should be low. That is called mobile robot. Mobile robot wheel configuration, how it should be moved. It should be moving in the one direction, or it may be moving in any direction. Center of the gravity, it should be very low. And robotic sensor, we are studying the number of sensors. Sensor is very important. So sensor collecting the information that is fed into the control unit, and the control unit fetch the input from the program, and based on this one, what is called, based on the robot will act. That is why sensor is very essential. Sensor is very essential. And what is sensor? Sensor is a converter that measure the physical quantity, convert into a signal that can be read by the observer. That is called, I am giving the definition. That is not needed. It's a converter that measure the physical quantity and convert into the signal. So what is the need of the sensor? Need of the sensor for the robot. So that is used for localization and obstacle detection, localization, obstacle detection, and an internal information. For three purpose, the sensor is used. What is the need of the sensor? Localization and finding out the obstacles and need the internal information. And sensor changes a robot from thumb to intelligence. Thumb to intelligence. It is not do the whatever instruction giving based on the intelligence, based on the information, receive information given by the sensor. It may be a intelligent one. The ability to adapt the particular surroundings, one definition of intelligence. So already we have the intelligent AC and we have the intelligent refrigerators. We have the intelligent AC means what? Based on the surrounding, what is called? The temperature can be adjusted. Temperature can be adjusted. So for that purpose, they are using the different sensor. The sensor read the temperature and send it to the control unit. Based on the information received from the sensor, temperature will be adjusted. That is called intelligent one. Robotic sensor. Robotic sensor provide the feedback to the control system and give the robot more flexibility. Already I explained. So provide the feedback to the control system. Sensor receive the information and send it to the control system, and it gives the robot more flexible based on the environment, based on the information received by the sensor. The robot may be more flexible. And sensor as a visual sensor are useful in building a more accurate and intelligent robot. Okay, then sensor can be classified as follows. Position sensor. So first one is position sensor. I'm telling the, I think somewhat it may be boring because it is a technical one. I cannot skip all the things. I can tell only the application, other things, where it takes around half an hour or 45 minutes. That's enough. But I'm going to tell what are the things in the robotics system, how it is operated. I'm giving only the tip of the iceberg. I'm giving only the tip of the iceberg because it is a vast area. You must know the mechanical. You must know the mechanical concept. You must know the electrical concept. You must know the electronic concept. You must know the software system concept. Okay, so it is a vast area. I'm giving only the tip of the iceberg. Okay. Position sensor. It is used to monitor the position of the joint. Okay, information about the position fed to the control system that are used to determine the accuracy of the position. Okay, information about the position is fed to the control system because already because control system control the entire system, so we have to give the proper information. The control system send the corresponding signal to the robot, then that will be position accurately. Then range sensor, and it is implemented in the end effector of robot to calculate the distance between the sensor and work part. So just like that is used in the what is called lift. Based on the image, the lift will be open or closed. The value of the distance can be given by workers on visual data. It can evaluate the size of the image and analyze a common object. So it size of the image and analyze the common object. Range is measured using the sonar receiver or and the transmitter or two TV cameras. Okay, range are sensor. It calculates the distance between the sensor and work part. Then it evaluates the size of the image and analysis of the common object. Here the range is measured using the sonar receiver and transmitter. Sonar receiver or whatever it is we can use, and that is used in the sonar system. Velocity sensor used to estimate the speed with which manipulators move, and the velocity that is used to estimate the speed with which manipulators move. So this is more important more important to improve the performance of the manipulator. What kind of meter is used? TC tachometer, that is normally used for feedback of the velocity information. Okay, and it gives the output voltage proportional to the angular velocity of the armature. Okay, this information is fed to the control unit for proper regulation of the motion. So velocity sensor receive the information. How it receive the information? What for what this kind of sensor is used? It estimate the speed with which manipulate is moved. Okay, what kind of technique you are using? TC tachometer, that is commonly used. Okay, that you provide the voltage, output voltage proportion to the angular velocity of the armature, and this information is fed into the control unit. Based on this information, the proper regulation of motion will be carried out. Proximity sensor used to sense and indicate the presence of the object within the specified distance without the physical contact. So that is called, that is used in the lift. When you are standing before the lift, so automatically it is open. So it sense or indicate the presence of the object. Whatever object you are present before the lift, so automatically it is open. Okay, what is the use of this kind of proximity sensor? That is used to prevent the accident and damage to the robot. Okay, what so the different type of robot is available in the proximity sensor: infrared sensor, acoustic sensor, and touch sensor, and force sensor, and tackle sensor. Okay, so these are the different sensor available in the proximity sensor. And tactile sensor, sensing device that specify the contact between the object and sensor. Okay, so just let us take the simple example for elevator button and lamp which dim or brighten by touching the face. Okay, and the two, it can be shorted into two key types. Two important type is what? Touch sensor, another one is force sensor. Okay, sensing device which is the contact between the object and sensor. And best example for is what? Button or elevator button or lamps which are dim or brightened by means of touching the base. And touch sensor, and we have the two type of sensor in the tackle: touch and force sensor. So ability to sense and detect the touching of the sensor or object. Okay, a simple device such as sensor, switches, limit switches. These are the example for the touch sensor. Okay, I'm giving the figure for this one. And force sensor used for calculating the force of the several functions like this, machine loading, unloading, material handling, and so on, that performed by the robot. So force sensor means what is called calculating the force of the several functions. So how much load it can have. So that can be the machine can have the how much load it can load, and unloading, material handling, and also used in the assembly process for checking the problem. Okay, and that is used a different technique, a joint sensing technique, or robot wrist force sensing, and tackle array sensing. And this is, we have the two type of sensor. One is called as external sensor and another one is internal sensor, already shown in the architecture of the robotic system. One is external, another one is internal sensor. So exterior, that is called contact sensor. First one is contact sensor. Okay, sensor that determine the size, shape, size, weight, sense the shape, size, and weight by means of touching. Okay, this is called the touch sensor. Okay, this is called external sensor. And force and stress sensor, to measure the robotic system force, how much the robot can do. What is the workload of this robot? What is the workload or work capability of the robot? And non-contact sensor, a simple example is what? Optical proximity sensor. Optical proximity sensor, right? Proximity sensor that sense and indicate presence and sometimes position also without physical contact. without physical contact. Simple example for this is shown in the slide. And this is photoelectric proximity sensor. Photoelectric proximity sensor, acoustic proximity sensor, capacity proximity sensor. It work on the principle of changing in the capacity with the environment. So based on the, it work based on the environment. A range sensor that is used in the radar and sonar. That is used in this radar and sonar. In the radar part, it sends the signal. It touch the object. Again, it will be received. The based on this one, we can find out the distance. Send their signal to the environment and measure the interaction of signal with the environment. So here it is used in this radar and sonar. And this is what video camera and record a signal already present in the environment, how much it covers, how much the video camera, how much it video camera cover, and that area will be sense. Ultrasonic ranging system, a machine vision sensor. I can show the different type of sensor we have. I cannot explain all the things. And tube type camera is also available. Using this camera, we can get any kind of information. Even in the tunnel, we can get the informations. Velocity sensor information. This is called external devices, external sensor. It may be a device or circuit or program or person. Okay, it may be a device, or it may be a circuit, or it may be a program. Okay, what is the use of this external one? Convert information from one format to another format. It can, the main external sensor is what? It convert information from one part to another part. How we are going to select your robot? This is a general one. So far, I'm discuss the what is called technical detail of the robotic system. So these are called a general one. How you are going to select the robot? How do you select the robot system? So there are four important factor we have to consider while selecting any kind of robot. The first one is size of the robot. Okay, maximum dimension of the robot workplace, maximum less than 1 meter, that is called micro. 1 millimeter to 2, or medium is 2 to 5, large one is this. So size of the robot is very essential. Based on your requirement, we can select this size. It may be micro, small, medium, or large. And degree of freedom. Degree mean robot contains the 6th degree of freedom. Robot contains the 6th degree of freedom, on which how much degree you need, how much degree of freedom you need. Based on your requirement, we can select. The cost of the robot increase with the number of degree of freedom. If the number of degree of freedom is increased, normally cost will be increased. Okay, and 6th degree of freedom, 6th degree of freedom robot can be used for all work. Okay, so first we have to decide the size of the robotic system. It may be a micro, small, or medium, or large. Then we have to select the degree of the freedom. So the degree of freedom maximum 6. Based on your needs, we can select the robotic system. You can choose the 2 degree of freedom, or 3 degree of freedom, or 4. But if you are increasing the degree of freedom, automatically cost will be increased. So next one is velocity. Velocity consideration affected by the robot arm structure. What kind of arm structure we are using? Whether it is a rectangular, cylindrical, spiral, articulated. Okay. What kind of arm structure you are going to use? Then drive type. What kind of drive you are going to use? Whether we are using the hydraulic power or electrical power, pneumonic power. Okay, so once you select the size, then freedom, velocity, drive type. The next one is control mode. What kind of control mode we are going to use? Whether you are using using the point-to-point control or continuous path control or controlled path control. So what control mode you are going to use? We have to select this one and lift capacity. Okay, we are going to use a lift or move. Then capacity, we have to specify the capacity 0 to 5 or whatever it is, and so forth. Okay, the based on your these are the different factor while selecting the robot. While selecting the robot, then let us go for robot operating system. And we have the separate operating system for robot. It is not as an actual operating system. It is not an actual operating system. It is just like a framework which consists of set of tool that provide the functionality of operating system on heterogeneous computer cluster. Okay, it is nothing but a framework and that contain the number of tools. Tools will provide the functionality of operating system on heterogeneous computer clusters. Okay, it usefully is not limited to the robot, but the majority tools provide are focus on working with the peripheral hardwares. So we have the number of tools on framework, and that framework is mainly used for working with the peripheral hardware. And this is called open source robot operating system, and which consists of set of software libraries and tool. And these libraries and tools are used for building the robot application, and that will be work on a different robotic platform. And this kind of OS is developed in the year 2007 at Stanford Artificial Intelligence Laboratory, and development continued below carriage. Okay, and it is managed by OSRF, that is Open Source Robotic Foundation. What is the main features of ROS? Main features, it has a two side. One is called ROS side, another one is called OS side. Okay, first one is operating system side, which perform the standard operating system services. Okay, first part is what? Operating system side. Okay, operating system side, which perform all standard operating system services such as package management, message passing between the process, low level device control, hardware abstraction, and file handling, etc. And second one, it has the number of contributed packages. That number, it contains the number of contributed packages. These packages provide the common robot functionality, such as slum, planning, perception, vision, and manipulation. Okay, we have the two sides. One is operating side, another one is a package side. The package is used to implement the common robot functionality. And this is called, I'm showing whatever I'm explaining in the previous cell, that will be shown. We have the two part, OS and ROS. OS and ROS, right? OS and ROS. And these are the big, main important website on which we can do such kind of operation. How we are going to install the ROS? The tutorial is available in the website. ROS cheat chart is available in this website. So okay, I can show the different website. Using this website, we can install, we can learn the ROS system. And how about using the what is the operating system you are using? I can show the different is. And ROS core concept. ROS core concept. And the first one is nodes, second one is messages, and third messages and topic, services, ROS master, parameter, stack, and packages. So these are the core concept of the any robot operating system. And let us take the first one. a single purpose executable program. ROS node nothing but a single purpose executable program. Example for ROS node is nothing but a sensor driver or actuator or mapper or planner, whatever it is we can use. Okay. And these nodes are individually compiled and executed and managed. Okay. This kind of nodes are written using the ROS client library that is called C++ client library, or either you can use the C++ or Python. Okay. The nodes can be published or suppressed to topic. Okay. Nodes can also provide or user services. Okay. RO is nothing but a single purpose executable program. It can be compiled and executed individually and managed. And these nodes are developed by ROS client library, that is C++ client library or Python client library. It can be published or subscribed to a topic. Topic is another core point. Nodes can also provide or user services. Then let us go for the next one, ROS topic. ROS topic. Topic is the name for stream of message with the defined type. The name for stream of type. Data from laser range. Okay. So we are getting the information from the laser, which contain the number of information. The finder might be sent on a topic called scan with a message type of laser scan. Okay. Laser beam is sent or laser ray is sent. The laser ray touch the object and collect all kind of information. Topic is nothing but a name for stream of message with a defined type. And nodes can communicate with each other by publishing message to the topic. How the nodes can communicate? One program, how the node can program is node is nothing but a individual executable program. So how this node can communicate with each other? So that can be communicated with each other by publishing message to the topic. Okay, publish a subset model can be a one to many broadcasting. So we can send from one to many topics. So this is the example for the ROS topic. And this is the graph you are using, where graph is used. We can show the ROS graph can be used and fetch item from the graph. How you can fetch a item from the graph and ROS messages. It is a strictly typed data structure for inter node communication. For inter node communication, and separate data structure is used, that is called as message, ROS message. Okay, ROS message. Okay, for example, geometry message is one example. Okay, that means what? It is a structure, data structure, which consists of the information, it is totally called as message. The message can be communicated with the all nodes. And ROS services. What are the services provided by this one? Synchronize internode transaction. Okay, RPG. Service to client model, one-to-one request and response, one-to-one request and response, client server model. And what is the role played by the ROS? Carry out remote computation, trigger functionality and behavior. So simple example for this one, maps server, static map, etc. So it provides a synchronized inter-node transaction. Internode, how the message is transferred from one node to another node, and that is the service offered by ROS. And also it offer the client server model. It offer the client server model. You know that what is called client send the request. The based on the request, server send the respond to the client. Okay, and service role, it carry out the remote computation and trigger functionality. ROS master. Okay, it provides the connection information to the nodes so that they can communicate, transmit the message to each other. What is the main duty of the ROS master? It provides the connection information, whether the nodes are connected between each other. Then only the node can communicate with the other node. Okay. And one point is important. Every node connect to the master at startup to register detail of the message stream they can publish. Okay. Every node should be connected to the master at the beginning, and also that specify the what kind of message stream I am going to use. Okay. And then any new node is appear, master provide you the information that needs form a direct direct to peer connection with other nodes. Okay. If any node is appear, the master will inform to the new node that we can make a connection connection with the existing node through the peer-to-peer connection. Let us say we have the two nodes, camera node and image viewer node. The camera node start first notifying the master, then it turn to the publish imaging on the topic. Okay. Camera node and it's in the a master. Then image viewer is added. Image viewer wants to subscribe the topic images to if there is maybe something image. So image viewer is added and the image will get the information from the master. And this is another example for this one, ROS master parameter server. This is called shared multivariate dictionary that is accessible via network API application program interface. What is called ROS master? ROS master, we have the talker and listener. Talker and listener. Talker and listener. Best used for static and non-library data such as configuration parameter. It is run inside the ROS master. So ROS it is called a shared multi-vibrant dictionary that is accessible via network API. What else? We have the listener and talker. They can communicate with each other through the API, network API. So ROS packages and software in ROS organized as a packages. So this all software and that is packages used in the what is called as in Java package is nothing but a collection of software, collection of software that is exclusively used for ROS. Okay, package contains one or more nodes and provides a ROS interface. The package contains one or more. Most of the ROS package are hosted in HitCub. Packages, what is the packages contains? Nodes, messages, and services. Okay, ROH packages system. So everyone is considered as a packages. How it can interact with each other. How it can interact. We have the stack contain the three packages. Repository having the two packages, stack and stack. ROS invoice contain the three packages. Okay, three packages. How it can interact with each other. This is ROS distribution release. How in which date these are released, that will be given here. And what are the ROS supported platform? ROS supported platform. Okay, now the ROS currently supported by Ubuntu. Other variants such as Windows, Mac OS are considered experimental. Okay, now it currently used in the Ubuntu software, Ubuntu OS. Okay, and in the Windows and Mac OS, in the trial version is used. ROS distribution support is limited to the less than 3 latest Ubuntu version. Okay, Jada support the following Ubuntu version. Okay, ROS Indigo support the following Ubuntu version, Trusty and Shaxi. Okay, so normally ROS supported only on Ubuntu, and the Windows and Mac OS only the trial version is it is trialed, and distribution supported is limited to less than 3. Less than 3. And Jada support the following Ubuntu version. So ROS Jada support the following version, and ROS Indigo support the following Ubuntu version. And top ROS companies. These are the top ROS companies we have. And let us go for ROS programming, robot programming. Already know that what is called robot programming. Okay, what is called robot programming? It is a defining of the shared motion so that robot can perform them without human interaction. What is called in the robot programming? We have to design. We have to define the desired motion. Okay, the motion command should be in the program. So based on this command, the robot can perform the operation without human interaction. So this is called what I am having the robot programming. One is offline, another one is online. Robot programming can be carried out offline or in the online. So some definition you most already you are familiar with this one, degree of freedom. Okay, degree of freedom and end effector. The degree of freedom of the robot will be numbered as Q1 to Q1, Q2, Q3, Q4 up to Q6. Okay, and end effector, end of the robot arm where the gripper or the tool that are the robot is located, it will define as a end point. How you are defining the end point, that is called end effector, that will be defined as P of E. What are the programming language, robot programming language? Either you can use the most widely used programs are C and C++, and now even the Python can also be used. Python can also be used. Okay. Auroban microcontroller use the programming language based on the C. Okay. That is great way to, that is Python, Auroban microcontroller use the programming languages. And these are the top popular programming language used in robotics. C and C++ is the top most. Why we are using the C and C++? Using this C and C++, we can interact with any hardware. We can control any hardware of the devices. So that is why C and C++ will be in the topmost position for developing the software for robotic systems. Okay, then Python. Python is the next, then Java. Even you can use Java and C Sharp or .NET. Even you can use the MATLAB programming. Hardware description language, Lisp and Prolog, industrial robotic languages, Scratch and Pascal. These are the top, sorry, top popular programming language in robotics. C, C++, and why you are using the C, C++? Using the C and C is called as low-level programming language. That means what? It can interact with the any hardware. We can control the any hardware using the programming code. Okay, and Python and Java is for web-based application. You are moving, your soft packages used in the web-based application, web-based. We can use the Java, .NET, or MATLAB, hardware description languages, because hardware description language is specially used for the particular hardware. So that we have to use the C and C++ and robot programming method. Whether you can use the offline or online or combination of both. Okay, robot program method can be offline or online, combination of both, right? And what is called offline? Sudha madam, you need any break or I have to continue my? Hello, Sudha
Sir,
ma'am.
Kindly,
you shall continue, sir.
Okay, okay, madam. Just 10 to 15 minutes I will complete this session. 10 to 15
Yeah,
minutes.
okay.
Okay. Tell your feedback. If you don't understand this one, please tell your feedback. Okay, I will continue. Okay, robotic program method, it may be online or offline, or it can be a combination of two. Okay, and what do you mean by offline? What do you mean by online? Write a program using the text-based robot programming language. Okay, text-based programming language does not need to access the robot until its final testing and implementation. That is called offline. Text-based robot programming. Text-based robot programming. It cannot be used. Right, online, use the robot to generate the program. Use the robot to generate the program. That is more teaching and guiding the robot through the sequence of motion that can be executed repeatedly. Okay, offline mean it is a text-based robot programming. It need not directly access the robot until it is tested and implemented. As far as online is concerned, use the robot to generate the program. That is called we are teaching or guiding the robot through the sequence of motion that can be executed repeatedly. Okay, and combination of this online or offline, and offline to define the task or sequence of operation. Offline specify the what kind of task you are going to what kind of task you are going to carry out. It may be move or pick up, whatever it is. Okay, and online it teach the location in space. Okay, location in space. Online, and that is called lead through. This is the advantage is easy, no special programming skill or training is needed. Okay, these are the different disadvantages. We need a large amount of memories needed, no practical for large and heavy robots, not a practical. Okay, and these are the different difficult to eat out the unwanted operator view, difficult to incorporate external sensor data. Okay, these are the different demerit of using the online, that is called lead through online. So online teach in and playback. A task, what is a teach in, what task you are carry out, transfer of appropriate program in the robot controller. Teach in what you are doing, you are transfer your program to the robot control, because which control the entire system. Okay, teach in process, teach, edit, control and correct and perform. Okay, teach in process la, first what is starting from the point, then edit and control gradually, next then correct. If there is any error we have to correct it, then we get carry out. This is a teach in process. So teach in process means transfer of appropriate program in the robot controller. Based on the program fed into the robot controller, the robot can perform this operation. So before performing this one, teach in process include these kind of steps. Teach Bentant PHP type to teach in program. That is called using the keyboard or function key, joystick, display, or these are killed. Okay, it enable long cable to a good view, emergency stop switch, emergency stop switch. These are the features available in this one, and these are the control equipment you are having. Type of robot program, you are having. Teach and coordinate system, join, world, tool, and free. You know that join, how it will be join, world, and tool, what is called free. Online tech box, online teach box, and easy, no program skill is needed, can specify other condition on robotic movement, trajectory use other line or arc, but it is potential dangerous. It is potential dangerous. We are using the teach box, we have the number of advantages, but only one disadvantage is what it is very dangerous. Online programming requires access to the robot. Program exists only in the memory of the robot control system, often difficult to transfer the document maintained, modified. Okay. Oh, so online program means what requires to access the robot. Program exists only on the memory of the robot, right? If the memory of the robot, we cannot make any changes on the program. And this is another program we are using, post programming language, playback language, task of sensor, offline. What is offline programming? Okay, what is offline programming and teaching methods? Teaching method satisfactory when only when the time for teaching in comparison to production time is very low. Robot must be used instead of for programming for the production. Okay, what is called offline? We are using the robot instead of human being. Okay, what production time is very low. When you are using the robotic system, automatic production time will be low. Okay, the robot can work while a new program is created. So what is called, it is reprogrammable. So you know that what is called offline program. Offline program contain the text based, and that will be compared, that will be checked, then it will be fed into the where control unit of the robotic system. So based on this command, it will be executed. Okay, so in the modern robot, the robot programs are independent of singly or in a total produce the production of industrial robot work. So normally, so some program can be interconnected with each other, and normally the most of the robot program are independent of each other. Okay, so the modern robotic system carry out this advanced robot controller, increase the absolute force accuracy, adaptation of sensor technology. Okay, the modern robotic system which provide this kind of feature or which adapt this kind of feature. This is called offline programming. Why offline programming? Okay, teaching, it's a time consuming activity. Teaching reduce the cost. Teaching in mass production, robot in small and medium production, and increasing the complexity of the task. Why offline program is very essential? These are the tasks carried out by the robot in the offline mode. Okay, these are the advantage of using the offline mode. Benefits of the offline mode: reduction of operating system time, dislocation of both ends of the danger of the robot, single robot operating system, and we can integrate the CAD and CAM system, access control, etc. These are the different benefits of the offline programming. Okay, offline, it may be interactive or explicit movement or implicit task. When you are going for the interact offline, it may be interactive system or it may be explicit movement or it can perform the implicit task. The type of robot programming, it is a joint level programming, robot level programming, it may be a high level programming. Okay, robot programming, it is a joint. So during the joint, we can write only the motion. And robot level or high level, basic action or position of the individual joint of the robot, and joint angle in the case of rotational joint, and linear position in the case of linear or prismatic joint. So how the joint can be moved, how the joint can be moved. For that purpose, we can write the program. That is called joint level moving. It does not affect the, it does not control the other part of the robotic system. It affect only the joints. Okay, joint. The robot level programming, the basic actions are position and rotation of P and the frame of reference attached to it. Okay, it is position and orientation. For positioning the things or orientation between the vertical, horizontal, xy direction, x direction or y direction or z direction, whatever direction, that kind of action can be controlled by the command written by the robot level programming. Then let us go for high level programming, that is called object level programming and task level programming. Then what do you mean by object level and task level programming? Object level programming means what? To be performed on the part and relation that must be established between the part. What are the operations? Pick up part A by side A1 and side A3. This is one operation. For this kind of operation, we can write the program using the object level programming. Move a part A to location. For that, we can use pick up a part B by side B1 and side B3. Put a part B on top of part A. So these are the different operations. These are the different operations. For this operation, we can write the coding using the object level programming. Task level programming and basic action performed by the program or complete task or subtask. So in this, each command perform the one task. Here we have the entire routine or entire program. Okay, entire program. Take for example, assemble the mobile phone, assemble the mobile phone or assemble the gearbox. For that purpose, entire program will be loaded in the control unit. or paint the car body red or green, whatever it is. Okay, for that purpose, it provide the entire coding will be available in the entire coding will be compressed as a program, combined as a program, and put it in the control unit. Okay, the last part of this one is economic justification of robot. Why you are using the robotic system? How much economy you can save? That is called payback period method. Okay, N net investment of the cost of the robotic system, including accessory, by net annual cash flow. N is the number of years the investment is paid back. Okay, payback period method. The first one is payback. We have to calculate the payback period method. So I am introducing the robotic system in my industry. What is the payback period? How much payback period? It may be 1 year or 2 year or whatever it is. So using this formula, we can find out what is a payback amount. Next investment cost, total investment cost of robot minus investment tax credit. Okay, that is called net investment cost. Net annual cash flow, net annual cash flow, anticipated revenues from a robot installation, including direct labor and material costs. Net annual cash flow. How to calculate the net annual cash flow? Annual anticipated revenue from the robot installation that include the direct labor or material costs, saving minus annual operation costs, include labor and material maintenance costs of the robot systems. So these are called net annual cash flow. So this is one example is given. That's not necessary. Net investment cost, capital cost minus tax credit. So I'm having this one, right? Simple example I'm giving. Annual labor cost, operator rate into number of operator into days per hours per day. Annual labor cost for single shift, annual labor cost for the double shift. So we have to find out the cost. Annual savings, annual labor cost minus annual labor maintenance operating cost. Okay, so we have to find out this one. For a single shift, how much you pay back period? For the double shift, how much you get back? So this is called economic justification. I'm giving the example for this one. So okay, thank you, ma'am. Hello.
Yes, yes, sir.
Yes, sir, ma'am. Have you any query? We can ask. Otherwise,
Right.
Participants, if you have any query, kindly unmute yourself and then ask question.
So one thing I have to tell that I'm only giving the tip of the iceberg. I'm giving the overview of the robotic systems. At some point, something it may be technical oriented. Because I cannot neglect it because I have to know. We must know that what is called actuator and sensor and other things. That is why I'm somewhat deep into the robotic systems.
Yes, sir. One
Yes.
participant has asked one question. The maximum range of robots to work.
Maximum.
Maximum range of robots to work.
Any kind of it is based on your application. Any maximum range means what? If it is industrial, the entire labor can be replaced by the robot systems. Entire labor can be replaced by the robot systems. Okay, but what we need, we have to invest so much of cost. Okay, and if you are going to use in the industry, it needs large space. Okay, it almost in all sectors it can be used, and all job can be carried out by the robot because and in the coming years the intelligent robot can be designed. Intelligent robot can be designed instead of human being. The robot can be introduced. So the best example, initially I told that the robot can be used for serving the food to the customer in the hotel. Okay.
Sir, one question, sir.
Okay. Yes,
Sir, you told about the gripper, the
yes.
hand gripper. Sir, can it be used even for the handicapped people who don't have hands? Is it possible for the robotics to join with human?
Why not? We can use this. Gripper is a separate program. Gripper, for the Gripper, we can write the separate program. And how you are going to include your Gripper into the handicapped person? That is another question, because we must have the control it in other things. Okay, so that give the information to the Gripper. Okay.
Okay. Sir, is
Otherwise,
there
other
any advancement in neuroscience related to the robotics, sir? Like for
new,
the handicapped person itself, neuroscience and robotics?
yes, definitely in the future that will come. So everything will be programmed in the microcontroller, and also the sensing device is also used. The sensing device sends the data, and that will be put into the microcontroller based on the information it received. Okay, based on the information received, it sends the signal to the what is called gripper.
Thank you, sir.
Okay.
Any other question?
Participants, any other question?
Okay, over to you, Sudama.
Thank you, sir, for your excellent speech.
Okay.
Now it's the time to deliver vote of thanks. I call upon Dr. Anita Indu ma'am, head of the department, computer application, shift 1. I call you, ma'am.
Thank you, Sudha. Thank you. Good evening, sir.
Good evening. Good evening, ma'am.
It's not happiness that brings us gratitude. It's the gratitude that brings us happiness. On this event, I am delighted and glad in delivering the vote of thanks for this day. First and importantly, I thank God for giving us hope and strength to stand still in the midst of ongoing pandemic. I thank the management, Principal Ma'am, and our Vice Principal Ma'am of Sri Shankarlal Sundarbai Shashun Jain College of Women for giving us this opportunity to witness an excellent event like this digitally. My heartily gratitude to our special guest speaker, Dr. Anantha Sivaprakasam, for spending your vital time to grace this event and for sharing enlightening words. I also extend my thanks to all the faculties from the School of Computational Studies for their excellent leading supervision and support. Eventually, I am thankful to all the participants for their cooperation and for accomplishing this event a successful one. Once again, thank you all. Thank you, sir.
Thank you, madam. Thank you for all the participants and the department and the principal, vice principal, and conveners and the coordinators of the this event, and also all the participants who are patiently hearing my speech, because it is morely technical oriented. So most of the speaker speech about the what is called application, other things, and it is somewhat technical oriented, because unless otherwise we cannot unless otherwise we can teach the technique, we cannot understand the robotic systems. So that is why I'm teaching the technical part, then I move on to the next one. So thank you for your patient listening, and thank you for the all the participants and the colleges and principal, vice principal, and HOD ma'am, and convener and committee members. Thank you. Thank you.
Thank you, sir.
Thank you, sir.
If anyone of you want to tell the feedback about this session, any participants, any participant want to tell the feedback about this session?
Sir, I'm Abhi from Viscom department, sir.
Yes, ma'am.
The session was very nice, sir. Like we are from different field, from visual communication, we are into graphics and animation. But
Okay,
we
ma'am.
learned new things about really new concepts about robots, sir. We are very
Okay.
much happy that you gave such a nice, wonderful session, sir.
Okay, ma'am. Thank you. Thank you. Thank you
Thank
for
you.
your compliment. Any feedback? Okay. Any feedback from the audience? Okay, madam. Thank you. Thank you for all, especially for the Sudha madam who communicate me. Okay. Thanks a
Thank you.
lot for all the participants. Can I wind up? Yeah, ma'am?
Yes, sir.
Yes. Thank you. Thank you
Thank you.
all.